This is the VHDL lecture series, and in this video we are going to see the designing of XOR gate. So we can also design XOR gate using the behavioral designing. We have already uploaded a video for AND gate designing in VHDL. That way also, by using the function, that is a logical function of XOR, also we can design XOR gate. But here in this video we are going to see how to design an XOR gate using process statement. Okay, let us see the designing of XOR gate using a process statement. So before seeing the VHDL code, what is actually an XOR gate? So this is the symbol of a XOR gate. A and B are the two input, and you will be having a XOR B as the output. If you see the various combinations of A and B, for 0, 0 output is 0. 0, 1 output is 1. 1, 0 output is 1. And 1, 1 output is 0. So you are getting the output as 1 only when A is 0, B is 1, and A is 1, B is 0. So only for these two combinations, you will be getting a output. Now, by keeping this thing in mind, we are going to write the VHDL code. Okay, so this is the VHDL code for a XOR gate. There is two sections. This is entity, this is architecture. So entity, inside the entity, we'll be defining the ports, and we'll be saying whether it is an input port, whether it is an output port, and the data type. In the architecture, we are going to write the functioning. That is the working of this gate we'll be defining in the architecture. So the basic entity declaration, what are things we are including in the entity, everything we have uploaded as a separate video. Okay. So if you don't know anything about entity of VHDL coding, please do watch the basic video. And here, what we have done is we have named the entity as XOR2. Why can't we directly write XOR? Is because XOR is a already predefined keyword in VHDL. So you are writing XOR2 is then port A is to in STD logic, B is to in STD logic. So this in is indicating that A and B are input ports. STD logic is a data type. We have already done another video on data types. Okay. Next is C, which is an output port. So it is out STD logic. Then end XOR 2. Whatever name you have given here for the entity, same name you have to give here also. Next, architecture behavioral of XOR 2 is then begin process A, B. So this working is actually depending on the two inputs, which are A and B. Based on these inputs, you are going to get an output, right? The C variable, which is the output variable, is going to get updated based on the various input combinations. So what I have done is I have put the variables A and B, which are the input variables or the input port names. I have put in the sensitivity list of my process. Okay. Again, another video is there for process declaration, sensitivity list and all. Please do watch that video. We'll get a very clear idea. Okay. So here what I've done is I have put the variables A and B inside the sensitivity list of the process. Then begin the process. If A equal to 0 and B equal to 1, then C equal to 1. So this only one bit. So we are giving single quotes. Then else if A equal to 1 and B equal to 0, then C equal to 1. Final close of if will be else. We are defining two conditions specifically, and for all the other conditions, we are giving an else statement. So else C equal to 0. End if, end process, end behavioral. Very simple coding actually, but you should understand it. So what we have done is we have taken the two input variables and we have put in the sensitivity list of the process. Based on this process sensitivity list, or based on this process signals, the output variable, which is the C, will be getting updated. If A equal to 0, B equal to 1, then C will be equal to 1. Else if A equal to 1, B equal to 0 also will get a C equal to 1. For all the other conditions, we are giving C is equal to 0. Okay. Then end if, end process and end behavioral. So this is the architecture design of the XOR gate. Okay. So the coding is actually having two sections, entity and architecture. I have not included the library files and all here. You have to add that also while doing this coding in the real software or IDE, that is Xilinx or some other softwares. So this is all about the VHDL coding of a XOR gate. So here we have not used any inbuilt functions for defining the XOR functionality or for doing the behavioral modeling. We have used the process statement. Okay. So if you are not using this process statement, you can also directly use begin C equal to A XOR B. Directly you can also use the XOR logical function. There is a logic function called XOR for XOR gate. There's a logic function for XOR gate that is predefined in the library of VHDL also. We can directly use that, but here rather than using the function directly, we have taken the process statement and we have defined specific cases for the A and B, and we have defined the output case also. Okay, so this is how you do VHDL coding of XOR gate. Okay.